Hello everyone, I am Xiaogang. Okay, I will skip the process of creating this file. Similarly, we create a map, create an actor, and then this actor is just a bare actor, right? Then we create a level here, and then we specify this level into our default editor development map. Then we simultaneously create a subclass of it, which is a blueprint subclass of this map actor, and then we drop it into the scene here. And right now, we haven't written anything inside. Okay, so we will start demonstrating to everyone using this environment. Okay, similarly, if we initialize it, it is through this way. Then here we pass our k-coordinate and y-coordinate. The former is the k-coordinate and the latter is the y-coordinate. So this is equivalent to an identifier for a fruit. Then we did not specify the allocator, nor did we execute the k function. So it will execute the standard allocation for and use the equality operator to perform an equality check on this Intel 312. Then use getUpHash for 3-column calculation. At this point, no memory has been allocated. No memory has been allocated. So if we fill it, we can do a filling through this add method and thus perform the filling. What you need to note is that if we look at this part, it appears to follow this order, but in reality, if you constantly add or modify it, its order will become scrambled, so don't focus on the order. It's the same as your addition order. Actually, it isn't. And if you add duplicate key and value, it will replace the old k value. Look at this spot, penar. This should be an ion, right? It replaced the ion with the Stratford one. And it can also call a key without a value. Its value is just a default value. It calls the default constructor of the value because we know that f straight is a structure. Its default constructor is an empty struct. Yes, that's what I mean. And you can actually use AppleX instead of add, and thus avoid the creation of this kind of name pile. Then it seems like there's too much. Let's finish watching this first. After we watch it completely, we can reproduce it. And because we all know, right? AppleX just directly uses this uniform string to create. It directly creates this. The fstream object inside this map without creating a temporary object to perform a copy or move. Then you can use the open one. It performs a simple append. Look at this place. New name, the second fruits man. And then you need to append it into the first one. And what is worth noting at this time is that the second one is now effectively empty. It's gone empty. And then this spot finally filled up with 1. And also in this location, it will also cover the element inside. Looking at 459. Actually, if you look at the previous 44 empty slots, it will cover, and this location is equivalent to, we can expose this container to the blueprint. Then let's execute this operation now. Okay, we'll do the same. Let's write a basic met class. This public. We can go a little faster here because we've learned this before. So there's no need. We can go over it a bit quicker because their actual thoughts are all pretty much the same. It's the whole concept and thinking process that we studied. Okay. We created a map here. Now we declare an empty map. Note that at this point, it hasn't allocated memory yet. And then when I practice this, if you go fine, there might be a problem. We will see later if we can reproduce this issue. Then here, we added 3 such elements separately. Right? Separately, these are 3 elements. And simultaneously, we add it here again. Then it will reset the previous element. This should be what I mean. Okay. Then let's go a little further. And we can also add this default one. Add a default one. It will build an empty container. Okay, there's nothing wrong with this part. Then we can also use a plus. EPES essentially goes and builds it directly. We add an EPICE There's no problem with this. Then this spot is essentially adding an appendage. So the 459 in this area, it should interact with the previous one, the 4. It will create a conflict and an overwrite. It will automatically clear the original 2 and then add it to the 1. If duplicates are generated, it will be removed. Okay. So we'll set a breakpoint here to take a look. When it loads, we can actually click into it and take a look at the code. Okay, it's in this spot. You just need to set this value. Using this key is equivalent to setting up the corresponding code, and this is related to this key, the key matching this value. And then this is the value matching this key. And finally, the return value type. It returns this. It returns a reference. This reference is a reference of a reference. It's a reference to the value of an image existing in this map, and this reference is just for use. Can be used until the next change. The value type should mean this. Okay. Why is it in this spot? Why does it return a value? Then we can actually do it like this. We can hook it up. Let me show you all like this. It should be called myFruit. Let's do it like this. It can connect to it, right? This thing is actually similar to what we learned earlier. It's basically like returning the last time you added this reference. They have a similar concept. We need to add an exclamation point. Let's execute and see the results. Okay, it means roughly this. So it's convenient for you to modify it after adding it. That's the idea. Okay. Good. Let's deliberately observe this. Then over here, we should need to specify this method. We have a sound in begin play. We have this function exposed to Blueprint. No problem. Okay, let's execute it now. We entered. Okay, at this point, we have a memp. You can see that it is NPT. It has no information. Then you can see the spot. It is chiswap mump base. It's derived class code. It's enter stream. This is its memory allocation. This is its key function, right? This type of LE code. Then we can look further down here. And over here, there is a parse. If we look up, then these are some things that are at a lower level. And in this area, after adding 1, you will find that, hey, it is also 4, right? And then this is Bala's exclamation mark. We added this exclamation mark here. You'll need to pay attention. This place has already emphasized it. If you implement it next time, it's possible that this location will be unusable. So, generally speaking, you shouldn't use it this way afterwards. It's better not to use it this way to avoid potential problems. Okay, we have 3 elements like this. No problem. We'll add another 2. These 2 will remove our grep freight. That means this element is removed. We can check if it was removed, right? It's removed. No problem at all. Then we are adding a default one. That is our value. It is a default constructor like this. You can see it's an NP type, an empty string, your default constructor. Okay, this is equivalent to adding an element if it's NP3. We don't generate this copy, right? It's placed here, right? And here, we've declared another one. This will overwrite 4 and 5. And previously, we had 4 and 5. We can see that 4 and 5 will turn into this. And this is the one that was newly declared. Let me open it again. Open it up. Okay, then we can see that originally this one. Let's look here and see why it will input. It's actually very simple, because when we get to this place, it is in the variable inside. We might need to hardcode a equals 1 here. Okay, let's run that again this way. Okay, this is the expected result of it. It needs to be added to the first map. Then it overwrites the duplicates, and then it will be cleared. Then we can simply take a look at this comment again. It also returns this reference, right? And the difference is perhaps avoiding the creation of temporary objects. As for this unparent, you can see that this place adds from one map to all maps. And then, if any case is in the boss, this value will come from, meaning it will be determined by this one later on. Right? That's the idea. Okay, we can see. Let's run it now. Then we will skip directly to this spot. Okay. After the report, we can see there are no problems, right? It's like this in our case. Pay attention to our pupil wing 4 and T5, 4 and 5. After it executes, you will find that it has become this, and then 5 became this. So it's something like this. Then, doesn't it have a multi-map? Let's demonstrate this multi-map for everyone. So let's also create a multi-map like this. It should be multi. Actually, the methods inside it should also be quite similar, but we just need to study the map because it's analogous. We should still add. Let's attach this place. Let's add to everywhere. Add it to the positioner too. And then, okay, this one is reporting an error. Let's take a look because we defined the name incorrectly. Because of its name. Generally, if it comes to naming, you can put it in these curly braces, but I still recommend that you use a unique name for it. Otherwise, sometimes if you enclose it in curly braces, it may cause compilation problems. But the logical structure between the top and bottom has issues. Okay, we can run it. We came to this point. Skip, okay? This one is empty, right? After we add 3 2s, actually, you can see that the letter K can be repeated, okay? So actually, it has multiple K values. Actually, when you query, it might return multiple structure. We will take another look at it later. Okay, so for this lesson, it hasn't finished yet. There's also this one. This can take a K value and reflect it into our blueprint. Okay, let's reflect it into the blueprint. Then we'll just let it my frame map. And for Keykograph, we generally prefer things like this. We usually like blueprint, readable and writable. And at the same time, whether we are debugging or implementing, it is always editable. As for our cut graph, we can write it directly like this. We just write xg like this. We can also write it like this. We xg f g t. We write it like this. Okay, let's look at our blueprint now. Okay, and then we come here. Good. We might need to gas default and then xg. Oh, because we found we can add it here, and we cannot allow adding this, right? We can add it. Apple, right? Then we give it a 22. For example, like this, just like that. We reflect it into the blueprint. And this variable, when we write code, it can also be used in blueprint. Something similar can also use it. Okay. So in this first section, creating the fill map is finished for everyone. Thank you, everyone.